Troubleshooting faults in a photovoltaic system is a tedious task because the highest level of PV system monitoring currently available is string level monitoring. Here we can see a string of PV modules. Currently, if a fault occurs in a string, technicians will have to unwrap and test each module to determine exactly which panel is faulty. To eliminate this process, the solar error detection system will be able to collect the operating conditions of individual modules wirelessly. This state transition diagram shows the essential operation of our system. The system will be in idle mode until the user prompts the master to send the interrupt to the slave. The slave will then read the temperature and voltage of each module and transmit this data back to the master. This data will then be displayed for the user and the system will return to idle mode. At the heart of our design is our microcontroller. We use Eagle to create a printed circuit board that will accurately obtain data from our solar modules. The design includes an Atmega 3208 that will suffice the required position we need with a 10-bit ADC. In the top left corner, we can see our onboard voltage sensor that will map a range 0 through 87 volts to 0 through 5 for the Atmega 328. Our design includes all through-hole components as this design was the best economical choice. It is also very similar to the Arduino Uno, which assists in developing our system by making prototyping and troubleshooting errors with the PCB much easier. It was a requirement for the temperature sensor have a range of -40 to 80 degrees Celsius, as these were the operating temperatures of the module. We chose the MLX90-614 because it has a range of -70 to 380 degrees Celsius and an accuracy of 0.01 Celsius. We chose the NRF24L01 since it operates at 2.4 GHz, which is a free frequency to use. It also includes a low power mode and only draws 0.1 microamps. We used Auto Inventor to design this enclosure to house our slaves on the back of the modules. 4 small pillars were included to mount the main PCB inside the enclosure. It was a requirement the temperature sensor face the back of the module, therefore an angle extension was added to mount the sensor. This design will be 3D printed. The solar error detection system will increase the efficiency of photovoltaic power systems by minimizing the downtime of the systems with string faults caused by failed modules. This will be economically beneficial to the owner of the PV system by reducing the time taken to troubleshoot a failed module causing a string failure. Simultaneously, by reducing the downtime of a PV power system, the solar error detection system will maximize one of the main roles of a PV power system, which is to be producing power via an environmentally friendly method. This is a demonstration of our slave transmitting the temperature of our module back to the master, which is displaying on a terminal. The PCB had all components soldered on with both the transceiver and the temperature sensor connected. The PV module was donated by Ryan Copley at Tico. The SEDS team consists of Jake, Jack, Kevin, and Ben, and Dr. Fair is our faculty advisor. Thank you.